So continuing with this kind of radical equation approach that we've been doing and looking at quadratics and all the other ones that we've looked at, I want to talk about a quadratic form. So we all know what a quadratic is, right? That was x squared plus bx plus c equals 0. Well, what if instead of an x, I replace it with something else? So instead of having an x there, I have something squared plus something, b times something, plus c equals 0. This is called the quadratic form. So it's when I don't just have an x, I have something else. So for example, if I were trying to solve the equation 2 times x plus 1 squared plus 3 times x plus 1 plus 4 equals 0. Well, this is of the quadratic form because you see it's 2 something squared plus 3 times something plus 4. My heart is x plus 1. So how are we going to solve this? We're going to pretend for a second. We're going to pretend that instead of writing x plus 1, I'm going to write a t. That changes the equation to 2t squared plus 3t plus 4 equals 0. So how do you solve this? Well, we would use the quadratic formula, and that would give us negative 3 plus or minus the square root of b squared, which is 9, minus 4 times 2 times 4, all over 2a. So that is negative 3 plus or minus, what's that going to give us? 9 minus 32. So negative So that gives us negative 23 all over 4. Okay, so we say this is not a real solution, so we say t is not a real solution. But t wasn't in our original equation. We're talking about x's here. Well, remember, x plus 1 was t, so if t had no solution, then x has no solution. So we say this problem has no real solutions. Okay, let's try another one of these. Let's say that I have 2 times s plus 1 squared minus 5 times s plus 1 equals 3. Well, it's kind of a quadratic equation. The only problem here is that we don't have it equal to 0, so we need to rearrange it. So I get 2s plus 1 squared minus 5s plus 1 minus 3 equals 0. And now you see it's 2 times something squared minus 5 times that same something minus 3 equals 0. So we're going to pretend. We're going to say, instead of looking at that something, let's let t be s plus 1. Then we're really trying to solve 2t squared minus 5t minus 3 equals 0. Well, use your quadratic equation. So the quadratic equation says t is going to be 5 plus or minus the square root of 25 minus 4 times 2 times negative 3, all over 4. So underneath the radical, what am I going to get? I have 25 minus 4 times 2 times negative 3, which is 49. Well, the square root of 49 is 7. So that tells me that my answer is either 5 plus 7 over 4 or 5 minus 7 over 4. Well, 5 plus 7 over 4 is 3. 5 minus 7 over 4 is negative 1/2. So we've taken this problem, kind of reduced it down and got t, but that's not what we were looking for. Remember, our original problem had s's in it. But we also know that t equals s plus 1. So remember, if one solution was t equals 3, our other solution was t equals negative 1/2. From this line, I know that that means s plus 1 equals 3, or s plus 1 equals negative 1/2. In this first case, s equals 2. In the second one, negative 3/2. So those are our two solutions. So whenever you see these, what we want to do is kind of rewrite it in something that we know. So rewrite it in terms of t. Then solve for your t value. Then go back and find your original variable.